Chris asked me to introduce him. I'd like to introduce Chris Dagdigian, the infrastructure guy for high-performance computing. Thank you, Chris.
Thank you very much. Morning, folks. Thanks for coming out. Actually, I'm going to start a quick timer to make sure that I don't go over time. That's one of my pet peeves on conference talks. All right, excellent. All right, so no pressure on me whatsoever. Thank you guys very much for showing up this early in the morning. For those who haven't seen me speak, I'm sort of infamous for speaking very quickly and having a huge slide deck. I tried to trim it down. I'm at about 87 slides for a 30-minute talk, and that's about dag normal. You know, we'll see. I've got to give this talk in Singapore in June, and I'm going to have to at least chop it in half because I can't speak this quickly in Singapore. The other thing is that even though I do go fast, a lot of the slides are reference material, and they'll all end up on slideshare.net at the end of the talk. So, you know, I apologize if I go fast, but there's, man, a ton of stuff to cover. So by way of introduction, yeah, I'm Chris. I'm one of the infrastructure nerds. I work for the BioTeam. It's actually a pretty fascinating company to work with, and I think our company has more to do with why I get invited to speak at these events than myself in particular. You know, basically, we're a very, very tiny shop of scientists who had to teach ourselves high-performance computing just to get our research done. We came up in the 90s when the Human Genome Project was going hot and heavy, and it turns out that there's a really interesting consulting niche if you want to do sort of honest and objective professional services, bridging the gap between science, chemistry, software, IT, storage, grids, clusters. It's very easy to find experts in one thing. It's relatively hard to find generalists who understand the chemistry, the biology, the software, and the hardware. And that's sort of our consulting niche. And PS, by the way, we're hiring. So stop by our booth today if you're looking for an interesting job where you can work from home. But one of the nice things about BioTeam, and I think the reason why we get invited to opportunities like this, is that as consultants, we're in and out of military, biodefense, law enforcement, big pharma, small pharma, biotech, nonprofits, research consortia, even startup companies that are sort of emerging from the venture capital fold. And because we're in and out of so many different companies, we get to see how lots of groups of smart people tackle similar problems. And also as consultants, most of the time we can speak honestly and objectively about what we see. So I think the real reason that I'm here, the real reason why I get tapped to do the trends talk all the time is that I'm in a unique position where I'm in and out of maybe 30 or 40 different companies or labs or institutions every year, and I'm in a position for most of them to speak honestly about what I've seen and what I've done and how many ways I've screwed up. So there is one bit of disclaimer. I'm getting a little bit nervous each time they sort of tap me to do this stuff. I'm just a guy. I'm just a guy who gets paid to do work. I'm not an expert, a pundit, a visionary. I make no effort to speak on behalf of an industry. I'm not a Gartner analyst. So, I'm biased, I'm cynical, I'm a little bit burnt out, and just, filter my words through that. Please just, I'm really desperately trying to stay away from the title of sort of pundit or visionary. I'm just really going to brain dump a lot of what I've seen and what I've done over the past year, and, nothing more, nothing less than that. So breaking down what I really wanted to talk about, I'll talk a little bit about business and marketplace type stuff, although like I said, we're not a Gartner, you won't get an analyst type view. A little bit of data center facility and infrastructure thoughts, a little bit more content on storage and clouds, and then sort of trying to wrap up with what I think are some of the interesting things that I'm working on now that might make it into the talk for next year. So basically on the business side of things, oddly enough, 2012 has sort of felt a lot like 2011. If we actually look at what our consultants are doing, we still have about 4 full-time people working on things like scientific analysis pipelines, a lot of next-gen sequencing, data management, a lot of sort of effort around our little mini LIMS product. Outside of that, we've still got 2 people, myself included, working full-time on facility and infrastructure issues. If I had to break it down, I'd say Chris Dwan is probably the big infrastructure guy. He's working on a lot of monster facility build-outs, new company startups, and I'm sort of the jack of all trades on the infrastructure side. I think looking back on my gigs, I am probably still about 40% infrastructure, 20% storage, and 20% cloud these days. And I don't know if anybody saw Adam Kraut's talk in the cloud track yesterday, but we've got one full-time awesome guy doing nothing but Amazon cloud projects, and that's probably an area where we will be scaling up and sort of hiring out this year as well. Generally speaking, the fact that the same teams of consultants are doing roughly the same work basically means to me that this year is a lot like last year. A lot of next-gen sequencing is still causing facility pains, although I think we're sort of over the most painful part. Although there are things that are sort of keep me awake at night, and I think those things that keep me awake at night are getting worse as sequencing becomes cheaper and cheaper and becomes more of a commodity. And I'll talk a little bit more about that in the storage section coming up. On the business side of things, companies are still spending. Even though economic downturn last year, we still, financially had a really great year. We still had more consulting projects than ever before. We're still sort of slightly concerned about the contraction in pharma, although I have to say, living and working in Boston is great because even the companies that are contracting elsewhere are expanding and hiring in Boston. So if you're East Coast based or Boston based, it's still a great time to be in life science. We have a number of government, military, and sort of law enforcement contracts. And again, not giving you the analyst view, we do sort of think the .gov stuff is starting to dial down a little bit. A lot of the stimulus-funded grants are aging out or are gone. Even some of the biodefense stuff that was hot and heavy a couple years ago, I think is starting to wrap up and go away. And you can even see this in the grant funding organizations and the publicly funded institutions. So I think on the meta side, pharma, biotech, and industry is still going strong. No huge radical changes that we've seen from 2011 to 12. Although if we had to predict that, I would say our sort of government work is going to start dialing down over the next year or two. On the facility side of things, it's actually been fairly interesting. We haven't had any new data center construction projects, which is a slight change from 2011. Most of the infrastructure stuff we've seen these days are, electrical and cooling refresh. People are refitting racks for higher density racks. They're going all out for blade, or they're realizing that designing high power racks that can only take blades is kind of a bad idea. So we're seeing a little bit of sort of, data center reconstruction or refresh, but not a lot of new groundbreaking. A lot of our clients are securing additional colo space. That's probably a new trend that we've seen. Some of it in the Boston-Cambridge area is just that real estate is too expensive to build server rooms, or actually if you desperately need that server room, you'll find out that the permitting authorities, Cambridge and elsewhere, are not looking friendly on new data center construction. Or they might be fine with data centers, but they're really not fine with the 500 gallons of diesel you want to attach to your emergency generator. So what we're seeing is a lot of people are moving out to colo space. And actually there's a lot of interest in sort of, I'm a cheapskate. I like the inexpensive stuff. There's a lot of movement towards the really serious tier 1 colos, and I'm talking like One Summer Street, downtown Crossing, Boston. And a lot of that is being driven not only for power and locality, but it's also because places like that are a great peering point. They're a great point if you need to freight lots of data into the cloud, and they're also a great peering point if you need to exchange data at scale with collaborators and colleagues. So, BioTeam is a cheapskate. I'd be looking for an inexpensive colo, probably ringing one of the highways around 128. Most of my pharma and biotech companies are really looking at the sort of much more expensive sort of tier 1 infrastructure providers, the ones that are based in downtown Boston, sitting right on top of the East Coast pop points. Last year we dealt a lot with power density issues. There have been a lot of facility designers who design their racks and KVA infrastructure to support sort of an even distribution of 400 CPU cores, 800 CPU cores per rack. And that started to run against a scientific trend we're seeing on the user side, where there's a ton of movement and a lot of justified business and scientific use for very, very beefy server nodes. We're talking, maybe 48 cores in a chassis and 512 gigs of RAM. Those machines are great. 48 cores, half a terabyte of RAM, they're $16,000 or whatever, and they might be only 2 or 3U. The problem is that those sort of 2U boxes have 1400 watt power supplies, and they were starting to play havoc with some of the older sort of designs that we had seen, where a facility manager had laid out a rack that was supposedly just to run 1U pizza box, or the only high density rack they have could only run IBM blades or HP blade chassis. It wasn't wired to support, some of these interesting rack mount chassis that might have extreme power supply requirements. The interesting thing is we haven't seen that sort of fight this year. People are more easily able to integrate the sort of beefy style of research computing nodes that are starting to become the standard. And for me, the standard, like I said, is 24 to 48 cores with a boatload of RAM. That solves a lot of interesting use cases for both genomics, assembly, as well as some of the computational chemistry, structure prediction stuff. It's a nice building block for a scientist, but last year it was a problematic building block to integrate at scale into a data center. This year we haven't really seen that many fights, and I think it's because it's been a lot of the power refit and stuff, or people are explicitly moving into high power density colos because they know from day one that they need to deploy these sorts of servers. We're still deploying tons of HPC clusters. I think my average cluster size these days is about 2,000 CPU cores, although it goes down to a few hundred and goes up to 4,000 or 6,000. Every single one of them this year has had a scale-out NAS attached to it. That's sort of an interesting trend in that I think scale-out NAS has sort of won the storage battle for our space. But the interesting thing is that every cluster that I built this year has included a VM platform grafted onto it at about the same level as importance as the admin node, the login node, the head node and the database nodes. And the interesting thing about HPC and virtualization is that it solves a lot of problems for me. There are very valid business and scientific reasons for a researcher or a scientist to have their own Linux VM. There's a lot of LAMP application stack. There's very valid reasons why a scientist needs a Linux OS to herself or himself. The problem is that that's a pain in the butt from a support perspective, particularly in an IT environment. Virtualization solves that problem by at least giving me a line in the sand where I can give a VM to a scientist and I can say, look, if you break the operating system, I'm just going to snap you back to a snapshot. I don't care what you do in the OS, it's on you, and the line in the sand when it comes to support is I'm going to give you your working server again. If you break it again, it's on you. It also solves a lot of other interesting things, and it positions us, I believe, to leverage some of the features that I would want from a private cloud without having to deal with choking on the endless BS being shoveled at me by private cloud vendors. And for me, the stuff that I want from a private cloud in my HPC environment, in my virtualization environment, is I want server catalogs that I can choose from, and number one, user self-service, user provisioning. You know, if I have a biologist or a chemist, I would really want to give them the ability to automatically provision, stand up, and use an operating system. And if I can steal that as a feature without having to go through the hassle of deploying a private cloud, I would much rather graft those features onto an existing enterprise VM platform than go through the ridiculous insanity required to deploy, you know, what people are calling private clouds these days. On the storage side of things, it's actually getting fairly interesting. It's still driving me crazy in 2012. It's probably one of the biggest sort of infrastructure pain points that I deal with on a constant basis. Although I'm not particularly worried about some of the stuff that I was worried about before. I mean, peta-capable storage is old news. There's a dozen vendors on the show floor today that could give you a petabyte array, you know, within a couple of weeks at your loading dock. Scale-out NAS seems to have won the battle. You know, we're not having a lot of huge storage architecture fights these days, and it's really just not as hard and risky to deploy big storage today as it was even a couple of years ago. A few years ago, it was a career-limiting decision if you screwed up. Now it's relatively hard to screw up, although you'd be surprised. On the other hand, there is a couple of things that do keep me up at night, and maybe it is time for a little bit of panic, particularly if you talk to some of the larger at-scale institutions. So this is where I'm supposed to scare you with a big scary graph. So you know, consider that checked off on the Chris's you know, Bio-IT presentation thing. But the real issue, if you wanted to sort of drill down to the real issue, is that we have a huge inflection point right now in 2012. We are acquiring data faster than the rate at which storage vendors are increasing the capacity of their platters. And what that means is that we're at an inflection point where it's getting cheaper and cheaper and cheaper and easier and easier and easier to simply acquire ridiculous amounts of data, but we're no longer able to ride behind the sort of Moore's law commoditization of storage. Storage is not getting bigger at the rate we're expanding our storage. That is absolutely going to cause catastrophic problems for certain organizations this year. And if you start talking to some of the large government research, you know, biotech institutions, you start talking to the large sort of human genome centers, and they're starting to see that. That is probably the single biggest sort of nasty problem that we're facing this year. It's easier to acquire. We're acquiring data at a rate that is now faster than the rate at which our storage systems are doubling in capacity. And you know, it really comes down to right now, a lot of our storage practices are unsustainable. It's an absolute fact that our chemistry and lab protocols change faster than we can refresh our data center infrastructure. We're used to laboratory protocols changing month to month, and if I'm lucky in a very high-funded biotech environment, I can refresh my IT every 2 years. It's much more likely that I'm refreshing IT every 4 to 6 years. So right now, when we're deploying storage and hardware, we're trying to guess what our scientists are going to be doing over the next 6 years, when the scientists themselves are changing what they're doing every couple of months. And that really is the risk at where we're at right now. This other bullet point down here is we are really bad at managing and tagging and curating our data. We are very far behind what sort of the media and entertainment industry, what some of the other sort of verticals have done when it comes to sort of treating data as an asset and applying sort of asset management strategies to data. It's still common in 2012 for scientists to think that keeping everything online forever on the fastest tier of storage is a viable demand to be making to IT. I still think IT has done a poor job of communicating to researchers the true costs of keeping data highly available, safe, and online. We really are at the point now for a lot of work. It's cheaper to delete the data and go back to the -40 freezer and repeat the experiment. But scientists, there's still a lot of resistance to that. I think if we don't address some of these things, we are going to have some fairly catastrophic issues this year. Although I think those issues are only going to hit the largest of the large providers. There's a lot of us sort of operating at the middle and lower tiers who have tons of headroom when it comes to storage and storage growth. CRAM is one of the things that I actually think is going to take off. I don't know if people have heard about this, but the basic deal with the storage problem that we're facing is that minor 10% or one-off improvements aren't going to cut it. Our field needs order of magnitude improvements in the way we store, capture, and compress data. One of the ways that it might come out of this is the concept of compressing genomes against a reference alignment. And the terminology was called CRAM. You and Bernie wrote a great blog post on it. There's a really interesting paper on it. I actually think CRAM is one of, I can't predict that CRAM is going to take off in 2012, but we need something like CRAM that provides order of magnitude level improvement in how we store things. And I think this also ties into a bunch of other trends, which I'm going to be talking about, namely that storage arrays are getting faster and smarter. We're starting to be able to run applications on storage arrays. And it wouldn't surprise me if sometime this year you were able to buy a storage array that was natively running CRAM compression and decompression algorithms. That's the sort of smart storage that I'm sort of hoping for in the next couple of years. So in terms of things that are coming next, honestly, we're all at the point now where we have to understand that science is changing faster than the IT. I myself have done a lot of nasty tricks to save my customers money where I would use tier 2 storage or nearline storage products to build out a primary storage array because my HPC customers were so freaked out about capacity that they were willing to trade off on performance in order to get the capacity that they needed. So I built a ton of systems with Isilon nearline storage nodes as kind of the primary storage tier. That sort of hack doesn't work now. We're back to needing storage tiers. We're back to sort of dividing up our storage among fast, medium, slow, and archive. And I think that's one of the major trends for me is a lot of the sort of cheesy tricks I had done in 2011 and 2010 simply aren't working in 12 because the nature of the workload is changing, and I actually do need high-performance storage as well as high-scale storage. I'm going to skip through a couple of these slides. I think I've got a better summary. I am still on my cloud storage kick. I think the economics are inescapable. The fact that object storage systems are just an HTTP call away, again, makes it to me, it's a no-brainer that this stuff is going to migrate into your storage array. If an object storage array, if an object store in the cloud is only an HTTP call away, it's incredibly trivial to build that HTTP call into the processor that's driving your RAID controller or the processor that's driving your storage array. And I think eventually Amazon or Microsoft or Azure is just going to be another checkbox on your storage array. Do you want to archive or do you want to shunt data into the cloud? More on this topic, the reason why I think storage is going to get smarter and more capable is that if you look under the hood of like a DDN, a Panasys, a BlueArc, or an Isilon, they're all running Unix or Unix-like operating systems on 64-bit architectures. And that means it is really, really easy to compile and run code on those things. Some of them are going the extra mile and putting in hypervisors so we can run VMs and stuff inside our storage. And I think you'll expect to see that more and more people talking about that and showing it off in 2012. So in terms of sort of summarizing, I think storage side, I think PETA-capable storage is still required for just about everybody in the room. I think if you're buying storage that you can only refresh every couple of years and your science is changing month to month, you have to think PETA-capable. I think a very, very small percentage of people will actually get to a petabyte. The problem is that I can't tell who in advance is going to get there. So, the rule of thumb for storage is PETA-capable. Scale-out NAS is still the best fit from a sort of ease of operational management and performance. There are other ways you can do things. My hack of using nearline storage, I think, is not something I can continue to sort of benefit from in 2012. And I think there will be some disruptive stuff coming up ahead when it comes to storage, either price disruptive, performance disruptive, or just cool stuff like hypervisors and CRAM algorithms, running deep inside the storage arrays. I've already talked over this slide. I think monolithic tiers don't cut it. I can't do everything I used to do with a nearline storage tier. I actually do have to start thinking about tiers, and I actually sometimes have to think about tiers that involve multiple vendors and multiple products and how to orchestrate them and integrate them together. I'm still very bullish on parallel NFS. It finally hit the show floor at supercomputing after a couple of years of sort of being in demo mode, and I think you're going to start to see more and more vendor products pick it up. It's also starting to show up in the operating system stack of Linux and Microsoft and elsewhere. And the moment a new protocol shows up in your operating system, the barrier of entry sort of drops really, really low. And I think that's the sort of inflection point at which things like PNFS should actually take off. I've already talked over the slide. Like I said, I think maybe the reason why I put this picture here is that storage arrays that are smart enough to run stuff are not only at the high end. This is an $800 Drobo array, and I'm running BioTeam's mini limbs appliance natively in it. There's a 32-bit ARM CPU and enough memory that I can run all sorts of interesting things in the storage. So If I can do it on an $800 home appliance, we certainly should be able to do it on an $800,000 enterprise appliance. I think the sort of opportunities for running stuff in storage is kind of cool. I'd love to run some of the storage resource brokers, things like iRods and things that you've probably heard about at other conference talks. The possibility of doing HDFS or sort of native Hadoop-friendly stuff in there is very, very interesting. And finally, I think for certain organizations, particularly those that don't have huge research IT support, the possibility of running some of your lab and lab management software in a storage array, in an appliance that's local to your lab, is sort of interesting. So I kind of like the idea of wikis and LIM systems, running on an array in a system that's fairly close to my instrument environment. I think I'm going to talk over this a little bit. Hadoop is in our future, even though most of us don't have people internally who can write MapReduce-aware code. There's a huge collection of open source people in the academic world who are churning out really good applications, and Hadoop really is the sort of way of the future when it comes to big data analytics. And if you're not using it now, you're probably going to have users or applications that we're going to require it this year. It's also a very interesting slam dunk use case. It's such a pain in the butt to integrate Hadoop into an existing HPC environment that in many cases it's actually simpler to draw a line in the sand and say, look, Hadoop runs in the cloud and HPC runs locally. One quick example of a disruptive storage example, I was kind of hoping these guys would be at Bio-IT World talking about their experiment, but I couldn't pull that off. This is a backblaze storage pod. We blogged about it extensively. The reason why it's disruptive is that it's 100 terabytes for 12,000 bucks. There are many, many, many reasons why you should never build one of these. There are many reasons why if you build one of these, you may lose your data and lose your job. However, there are very, very interesting use cases for a $12,000 box that gives you 100 terabytes of raw storage. These are real pictures from a real consulting engagement, and I have a real biotech customer that's doing some really interesting stuff with this. And it's the type of thing that I think you have to be very, very careful about. But man, 12,000 bucks for 100 terabytes is pretty attractive, and I'm betting you can think of some interesting things to do with a backblaze pod. We've blogged about it a lot, including pricing and other stuff if you want to check that out online. When I say the future feels like this, let's see if I have my mouse pointer up. No, I don't. The future doesn't feel like this particular infrastructure, but if you tease down the bits that are in this picture, there's EMC stuff on the right, which is kind of my tier 1 stuff. There's tape and data dedupe on the left, which is kind of my tier N stuff. And then in the middle, I have the sort of disruptive tier Z stuff. And I think that's sort of what the future feels like to me. I don't think I'm building monolithic single namespace storage arrays anymore. I'm probably using multiple products, multiple vendors, and probably doing some sort of interesting thing involving a mix of high-end and low-end products. All right, I can't do a Bio-IT World talk without the C word, so I'm going to get into some cloud and check in on my time thing here. All right, so I've got a few minutes left. I'm pretty blunt and cynical. So before I get mean, I just do want to say that I'm not an Amazon shill. I'm a guy who only gets paid if I build stuff that works. And right now, when it comes to the cloud, Amazon has more building blocks that I can use to assemble things that work and thus allow me to take home a paycheck. I mean, I am a cynical, zero loyalty person, and I'll happily switch to the next service or vendor that gives me an easier way to solve customer-facing problems. Although, truthfully speaking, at this point, it's difficult to see anybody capturing, any sort of infrastructure cloud crown from Amazon. So, a little message to the people who are sort of trying to come up in the infrastructure cloud space is, there's a lot of hype and a lot of BS, and I get really angry about it, so this is my chance to sort of vent at the vendors. If you don't have an API, you're not selling a cloud. If I can't self-service my infrastructure, you aren't selling me a cloud. If you just install VMware and excrete a press release, that's not a cloud. I'm sorry. It's not. If I have to email a human being to light up servers or storage, that's not a cloud to me. If I start up 100 servers and only 50 come up and the rest are stuck in sort of an intermediate state, that's not a really usable cloud. This is a real example, by the way. And finally, if you're just offering block storage and virtual servers, yeah, you've got a cloud, but you've got a cloud that's just like 30 other clouds that people are sort of operating and selling. And so one of the differentiating characteristics between infrastructure cloud providers is that there's an infinite number who basically offer this, and there's a much smaller subset who are building all sorts of other layer products. And I'm an infrastructure guy. You can almost think of me as a systems integrator. I can't build stuff without building blocks. So on a cloud platform, the more building blocks I have, the more stuff I can do. And frankly speaking, these are not enough building blocks to do scientific computing on the cloud. That's the baseline. It's what I need to do anything. but there's a whole bunch of other stuff I need to do on top. And again, not being an Amazon shill, if you're wondering why Amazon is so popular or why BioTeam uses Amazon a lot, it's that Amazon has 30 or 40 different building blocks, and they're adding more each month. And all the other competitors basically have block storage and virtual servers, and that's basically it. So on the private cloud side, I have come around a little bit. If you saw my talk slides from a couple years ago, I think I used the words utter crap. That's no longer the case. I'm actually becoming a lot more positive about private clouds. Although I think the hype versus reality ratio is still a little bit skewed, and you have to do a lot of careful due diligence. If you actually drill down into the private cloud technical requirements and truly see what you have to do to your networking environment and your hardware environment, you'll see that it's not as easy as sort of the vendor hype would indicate. There's also easier ways to get what I think are the best private cloud features, which for me is grafting those features onto my VM platforms rather than trying to do this from scratch. So the advice here is be a little bit cynical. We're still very much in the hype phase of private clouds. And I probably would not deploy a private cloud solution that did not have Amazon API compatibility. So when you're looking at OpenStack, CloudStack, Eucalyptus, and all the different providers, I would say Amazon API compatibility is not a requirement, but there's such a huge ecosystem of tools, libraries, wrappers, and helper utilities that you can get a lot farther if you had Amazon API compatibility than if you don't. And if you don't, you better be buying your private cloud from a vendor who's big enough to sort of self-service and fund some of these open source developers. I'm not a guy who talks to APIs. I never talk to the Amazon API service endpoint. I use libraries, wrappers, and utility scripts that talk to the Amazon APIs for me. The reason why I have these libraries, wrappers, and utility scripts is that a whole bunch of open source people have written them, and they all speak Amazon. That collection of useful utilities and wrappers is going to be much, much, much smaller if you step into a cloud product that has sort of abandoned the Amazon API, or for business reasons or even technical reasons. There are valid reasons to do it. I'm just saying you need to understand that when you go away from Amazon capability, you're losing a little bit of this sort of open source ecosystem that's already created a lot of very useful and interesting tools. I skipped this. I've already talked over this. I think most people are better off extending the capabilities of their existing virtualization platforms rather than going all in on private clouds, at least in 2012. So my basic advice on the cloud stuff here is that you need a cloud strategy, and if you don't, you're going to be bypassed by your users. And frankly speaking, the infrastructure cloud is only a credit card away, and there are some scientists who are too important and will not be fired if they violate IT policy. And we've seen this a couple of times. If you're an IT organization and you don't have a credible cloud policy, your users are just going to take their credit cards and go do it on their own. And some of them are junior enough, and you might be able to get them in trouble and get them fired. Other ones, you're not. And so you really have to have a credible strategy here. The other thing that's really changed, and I actually changed this when I started talking about cloud stuff a couple months ago, you actually need 3 tested cloud reference patterns. You need a cloud design to handle all of your legacy scientific computing use cases, the BLASTs and the HIMMERs and the Mr. Bays and the phylogenetic apps. There's hundreds of applications and algorithms that we're never going to rewrite for a Hadoop, and we're never going to rewrite to run in sort of the cloudy elastic framework. So you need a cloud framework that can run your existing legacy HPC applications. You need a second one that can handle the applications you deem worthy of being rewritten for the cloud, applications that are worthy of being rewritten for the elasticity of the Amazon Spot servers, or that pass message and state information via cloud messaging systems. That's an interesting area. And then finally, you need a third solution for Hadoop and big data, mainly because the way you do Hadoop and big data is different enough from the cloudy stuff and different enough from the legacy stuff that they really are sort of 3 different design patterns. So on the legacy HPC stuff, I'll just say one and done. I think Justin's even at this conference. MIT Star Cluster. It builds self-assembling clusters on the Amazon cloud, your choice of Grid Engine or LSF or Open Lava schedulers. MPI is there, NFS is there, all the numerical libraries are there. It's a way to stand up an HPC cluster in the cloud in a matter of minutes. It's an amazing tool, and it's probably our baseline for doing legacy HPC use cases today. The cloudy area is where you have the most freedom. This is where you have an application or a pipeline that's worth investing software development time to rewrite for the cloud. But the interesting thing about this is that how variable this is and how many choices you have. I can tell you today what BioTeam's design pattern is. Whoops, that's my time limit. I can tell you today what BioTeam's design pattern for this is, but I can also tell you that Amazon just came out with Simple Workflow Service a couple weeks ago, and that might radically change the way we do sort of cloudy elastic pipelines. So that's the problem here is you have a lot of freedom, but there's a little bit of uncertainty in this space. On the Hadoop side, It's going to be a map-reduced world. That is the future of big data analytics for all industries. But the interesting thing about this is that there's very little need to roll your own Hadoop. There's so many commercial companies that will deliver a really easy-to-use Hadoop solution, either on-premise or in the cloud. There's open source options. There's commercial options. To me, really, the only advice about big data stuff is that I'm definitely in the camp, at least for most of us. It's not worth the effort of rolling your own. The ecosystem is out there. It's way too easy to commercially acquire it yourself. So a little bit on the cloud data movement. I've slung a ton of data, 30 terabytes at a time or more, in and out of the cloud. And you might have seen pictures like this where I show real infrastructure pictures. Data transfer station, a couple of terabytes moved via naked SATA drives in a toaster. All this stuff are really valid ways that we slung data around the past couple of years. This is an example, again, of sort of naked data archives at scale, a shelf full of SATA drives. But really, I've got a new story for 2012. And the real reason is because of this graph. This is a graph taken in March where we sustained 700 megabytes a second for more than 7 hours pushing data into Amazon. At that rate, I can handle a genomic sequencing core facility, and I can push I can push 60 genomes a day or whatever at that particular rate. So what's that changed is that if you actually drill down and look at high-speed data freighting, the operational burden, the hassle of MD5 checksumming, the infrastructure you need, and the people you need, it's actually very difficult to move data physically with human beings and SATA drives and FedEx. And what we're looking at now is the cost of internet connections. The gigabit Ethernet connection is getting cheaper, and using something like Aspera, which really is sort of no-brainer for sort of high-scale data movement. What's happening is, trend-wise, we're moving the dial back. I think we're starting to promote network-based data movement over physical data movement, where we had been doing a lot of physical data movement in the past. Duan has a great webinar where you can double-check my math, and he talks about supporting core facilities, with this sort of bandwidth, and so you can check us out there. So I've already talked over this slide. So you've got a couple of different options. You can buy software from Aspera and be done with it. You can do what we do, which is go to supercomputing every year and see what group of smart kids wins the bandwidth challenge, and use whatever software they wrote that year. But finally, you can also talk to the Grid FTP folks who actually have a booth down on the floor. And the anecdote about Grid FTP is that I go to a lot of talks, and every single talk I've been to about data movement, if the speaker is not an Aspera customer, they're a glowingly happy user of Grid FTP. So the nice thing about that is you've got the commercial option, you've got a nice open source option, and some stuff in between. So there's a lot of freedom here, and I actually am sort of a big fan of the network data move. So on this thing, so Grid FTP has a booth, and also I don't know if you've ever heard Michelle speak, but she's a genius. She's a really, really great speaker, and I think in track 2 later on this morning, Michelle from Aspera is going to be talking about this in particular. So finally, I think I'm right at the end of my time limit. Just some stuff that might become topics for next year, things that are interesting. I don't know how many people saw what Baz did at 8 a.m. yesterday morning, where we actually demoed using Siri on an iPhone to control Pipeline Pilot running on the British Telecom cloud. So we're sort of bullish on interesting lab experiments, and I think we're going to be doing more with this. Expect to see more BioTeam blog posts and white papers on sort of voice control and Siri, and sort of taking orchestration to the next level by using voice as an interface. It was actually kind of a cool demo. And there's a recorded screencast at that URL if you missed it at 8 o'clock yesterday. I'm a big fan. I mean, I've talked enough about this, about the concept of storage arrays getting smarter. There's some really interesting opportunities, I think, for a small lab and a small organization perspective, for interesting servers, interesting packaging, interesting appliances. So, I'll be doing a lot of stuff ranging from Drobo to Data Direct, but I've also been playing with this box here, this Intel modular server. It's got some very interesting capabilities for, I think, small research organizations and sort of support limited environments. I've got a thing right now where there's an interesting built-in hypervisor running BioTeam mini-lim software. The second hypervisor is running the Amazon storage gateway on the idea that this little appliance could be blasting data into the cloud as an archive. And the third blade is actually running Bright Cluster, which is a cluster stack that knows how to cloud burst into Amazon. So in this little lab local appliance, I have my LIM software, I have a storage gateway that's blasting data into the cloud, and I have a scalable HPC cluster that can cloud burst theoretically if needed. This is all just running in my basement right now. It's all sort of proof of concept, but it's sort of the stuff that I expect to be focusing on and maybe talking a little bit about next year. I'm going to skip the little screen cap stuff, except to say that I like hardware that comes with native hypervisors and just lets me drag and drop stuff. It was very, very easy to get this thing up and running. That's just the Bright Cluster stuff running in there. We're going to continue hitting orchestration and cloud stuff pretty hard, and that's all I'll really say about it because I want to end this thing reasonably on time. So I think that's it. I'm done. Although I think ops code is here, and if you're interested in DevOps and infrastructure automation, if you find an ops code booth, they're definitely worth checking out. So thank you very much. I appreciate it. That was 87 slides in 30 minutes, and the slides will be up online at SlideShare. Thank you very much.